So now let's look back into, now that we're starting the second video, let's think about changing or trading between two people. So let's start thinking about the exchange economy. So the exchange economy is this interaction between two individuals, and so the models are the simplest form of economic activity. So let's just think about any trade between two parties in some interrelated market. So what this means is that there's going to be two consumers and two commodities. And each consumer is going to have some initial endowment of those two commodities. It could be zero, but they're going to have some initial endowment of those two. And the total endowment between the two individuals is the total supply in the economy. So they can't go and find it elsewhere. They have to just do it between the two. The distribution of supply endowments may change, but consumers can exchange goods to attain better consumption bundles. And so, for example, suppose there are these two neighbors, Jane and Denise, and they live deep in the woods, isolated from everybody else in the world. They each have an initial endowment of both firewood and candy. So Jane has 30 cords of firewood and 20 candy bars, and Denise has 20 cords of firewood and 60 candy bars. So let's assume, let's draw them on separate indifference curves. So if we put candy bars on the x-axis and we put firewood on the y-axis, then we can draw this indifference curve. And then let's say, actually, let's make this a little bit higher. Yeah, there we go. We can then say that this endowment here, and let's say this is for Jane. Jane would have 30 cords of firewood and 20 candy bars. And if we do something similar for Denise, let's say that Denise is further down this way because she has more candy bars and less firewood. Then we would be able to draw both of these on an indifference curve. So let's call this EI, maybe, and EJ. So one of the things that you should notice is that we can combine these two to make what we're going to call an Edgeworth box. And so an Edgeworth box takes this initial endowment here, and it takes this red indifference curve and plots it on a box. So if you notice, these here, this 80 and this 80, are the total supply of candy bars because we've got 60 plus 80. Similarly, we have 50 and 50 bundles of firewood. And so if you notice, this box that we're making is essentially just what would happen if Jane could potentially have all of the firewood and all of the candy. And then it's flipping. So, right, so this would flip the other direction. So imagine we could take this and rotate it so that this indifference curve would match this indifference curve. Right? So for Denise, our indifference curve is still convex to her origin, and Jane's is also still convex. But now we've got these strategic interactions between these two that could matter a lot. And if we notice that this combination here, this first E, is the current combination that we have. So Jane has 20 candy, Denise has 60, Jane has 30 bundles of firewood, Denise has 20. So A would be this area of improvement that Jane would be able to expand into, right? Because her initial indifference curve is setting the lower bound. In order for Pareto improvements, she can't be worse off, so she can't regress closer to her origin. Similarly with Denise, B is her expansion path, and she would want to improve in that direction. And so there is this box in here where we have, and I'm going to draw this in orange, there's this box in here where the two individuals could exchange goods back and forth in order to reach a more reasonable optimum here. So, for example, suppose that Jane improved to 40 candy bars and decreased, so Jane traded 10 pieces of firewood for 20 candy. So she decreases but increases. And so she moves from E to F. Similarly, Denise does the opposite. So she trades 20 candy for 10 firewood. And so she declines here but increases here. And so now they're both at F, which is an improvement for both individuals because they both are on a higher point that would be above their original indifference curve. And so the Edgeworth box is this kind of weirdly, like it looks super complex to think about it, but at the same time, it's pretty straightforward. It's just comparing the two indifference curves, but using it to kind of juxtapose two individuals that would be able to improve from trading. And so we can build on this a bit more, right? So we can talk about trading. So without trading, the consumers would only consume their initial endowments, right? So we would be stuck at E. But with trade, we would be able to move from E, so off of this indifference curve, into F on both direct from both for both people. And so the height of the Edgeworth box represents the 50 piles of fireworks. The length represents the 80 candy bars. Bundle E is both endowments measuring from Jane's origin in the lower left and 30 piles and from Denise's origin at the upper right. But we would be able, through trading, to move from E to F. So should Jane and Denise trade? Well, ultimately, it depends on their indifference curves. It depends on their preferences. But given that example that we used before, yes, they should. And so we're going to make a couple assumptions about their taste and behavior. So first, Jane and Denise are both utility maximizers. They want to get on the highest indifference curve as possible. They have convex shaped indifference curves, which means that they point away from the origin. And so each person's indifference curve has the usual convex shape that we need. They also have this thing called non-satiation, which means that each person has a strict positive marginal utility for each good. So that means that both goods are normal for them, and it means that they don't get tired of one good compared to the other. And there's going to be no interdependence. So neither person's utility depends on the other person's consumption, and neither person's consumption harms the other person. So there's going to be like no pollution that occurs. And so they're just going to be only positives from this consumption. And so we're able to come up with all of these things that would be even further. So if we were able to bounce back and forth between each of these endowments, right, we would be able to generate a lot of improvements. And so suppose that A, B, F, C, E, D, and G were all potential endowments that each individual would get. Um, Obviously we start at E, right? And so this is kind of a busy line. The blue lines are potential indifference curves for Denise. The red lines are potential indifference curves for Jane. So it's good thing to note. Jane benefits from moving this way. Denise benefits from moving this way. So E is where we are starting. We would be okay at B. That would be a Pareto improvement. Because Jane is on the same indifference curve, right? So Jane is still on this first indifference curve, but Denise gets to bump out to this new indifference curve. This would be a Pareto improvement. Similarly, if we went from E to C, this would be the same indifference curve for Denise, but Jane would be able to bump out to this new indifference curve and she would have her improvement. So she would get to move from here. And when we were at B, Denise would get to move to here. Now, if we were thinking about this further, would moving to D make sense? No. This would not be a Pareto improvement. Although this would be a huge benefit for Jane, Denise would have to suffer too much of a loss in order to make this worthwhile, because she would be regressing from her initial indifference curve down. And so that would not be a point that would be worth. Same with A and G. Both of those would put people on bad indifference curves. And so there's only four potential options that would be Pareto improvements here. It would be E, B, C, and F. E, B, and C would be Pareto improvements because they benefit one person. But if we look a little bit further from trade, F would be a Pareto improvement for both individuals because it provides benefits for both. And so it would be an improvement not only for Denise or for Jane, but for them together. And so moving from E to F, doing this trade in this box, allows us to generate this thing called the contract curve. And so this black line that goes through here is a contract curve, which essentially says that in order to move along those lines, those would be acceptable trades that would map onto indifference curves. So it would be where the two indifference curves are tangent to each other along all potential options. And so there's only going to be a couple potential options on the contract curve where these would be valid, right? So only combinations on here would be where one, the indifference curves, the two persons' indifference curves would be tangent to each other, but also two, that where the contract curve would allow individuals to exist with a Pareto improvement. So one, the contract curve allows them to do it because the indifference curves are tangent, and two, it is going to be a Pareto improvement because it is going to benefit at least one individual, if not both. So the Pareto improvements through trade are possible when the indifference curves intersect. And so the Pareto efficiency is achieved when indifference curves are tangent. So what about B to C? Is a move from E to B a Pareto improvement? Yes. We talked about this. And a movement from E to C is also an improvement. But what about moving from F to B, right? So what if we were here in the center and we moved back to B? Unfortunately, that is not a Pareto improvement because it would harm Jane from that initial starting point. And so all of these Pareto improvements all depend on initial conditions and they all depend on the initial allocation of resources. And so that regression from F to B harms Jane in this decision, although it does benefit Denise again. And so that would not be a Pareto improvement. And so what about the origins? Again, that would also harm one individual. So we'd already talked about a little bit of these. And so who wins the trade? It's going to be the one with the bargaining power. So, right, each individual here is going to want, like, they would be okay with improvements from both. But Jane knows that she would be able to move up to C if she can get Denise to just trade without her giving up any or without her moving off of her initial indifference curve. And so this is where bargaining power comes in tremendously. And so no further trade is possible at a bundle like F. At F, Jane's marginal rate of substitution, so the slope of her indifference curve, between Wood and Candy is going to be equal to Denise's marginal rate of substitution as well. And so four equivalent statements can be made about the allocation F. The first is that indifference curves of the two party are tangent at F. The party's marginal rate of substitutions are equal at F. No further mutually beneficial trades are possible at F, and the allocation at F is Pareto efficient. So one party cannot be made better off without harming the other. Um, so then there's this contract curve. Um, The contract curve contains all of the Pareto efficient allocations. So any bundle for which Jane's indifference curve is tangent to Denise's indifference curve lies on the contract curve because no other further trade is possible. Jane's marginal rate of substitution is equal to Denise's marginal rate of substitutions, so we can't reallocate goods to make one of them better off without harming the other. And so the Edgeworth spots when we start to introduce prices is let's stop bargaining and trade goods based on prices. So given the prices of two goods, a price line can also be added to an Edgeworth box in order to illustrate combinations of goods that Jane could get by trading given her initial endowment. So where do these prices come from? Well, going back up here, let's assume that the price of firewood was $2 and the price of a candy bar is $1. Then we would be able to draw this line for Jane that would draw along this way. For Denise, it would be, we would start at the initial allocation Sorry, I gotta flip this upside down. Um, for Denise. Oh, that it's gonna be the same line. Gonna be the same line. The slope is minus one half, right? And so why does the price line have to go through E and F? Well, because it is going to be an efficient allocation between the two. What about the intercepts? The budget line for Jane is going to be the same thing as the budget line for Denise. Well, they're going to be similar, but they're going to be the endowments that each individual would have and would receive originally are going to be higher. So remember, the initial endowment, Denise had 60 pieces of candy times 1 plus 2 times 20. And so for Denise, she had an initial endowment of 100. For Jane, she had an initial endowment of 80 because she had um 30 pieces of firewood and 20 pieces of candy. And so when we start to think more about these price lines, all of these relative prices are Jane selling wood to Denise and Denise selling candy to Jane. And so they're going to trade back and forth until they reach that Pareto optimal. And so at F, the quantity demanded is going to equal the quantity supplied. And so F is going to be a competitive equilibrium. So our marginal rate of substitution for Jane is still going to equal our marginal rate of substitution for Denise, but it is also going to equal the marginal rate of transformation between the two goods, which again is the negative ratio of prices. And so now we can add in this concept of efficiency back into this result. So since the competitive equilibrium must lie on the contract curve, we have demonstrated the first theorem of welfare economics, which says that any competitive equilibrium is Pareto efficient. So the intuition for this result is that people who face the same prices make all voluntary trades they want in a competitive market because no additional voluntary trades can occur in a competitive market. So no reallocation of goods would make someone better off without harming someone else. So in other words, if an involuntary trade occurs, it will harm someone. For example, a person who steals from another person is an involuntary exchange and it gains at the expense of the victim. There's also these things called intervention that we can jump into. So by adjusting the initial endowments, we demonstrate the second theorem of welfare economics, which says that any Pareto efficient equilibrium can be given by appropriate endowment and lump sum transfers. So the first welfare theorem tells us that society can achieve efficiency by allowing competition. The second says that welfare can add to society by obtaining the particular efficient allocation it prefers based on value judgments about equity and appropriately redistributing the endowments. So, if we were already at E, the government can essentially just say, nope, we're going to take 20 pieces of candy from Denise and we're going to take 10 pieces of firewood and we're going to swap them back and forth. And so that would be an intervention. And so how else can we achieve a chosen Pareto efficient point? There, we can move endowments to other points on the price line and show what happens. And we can also move endowments to anywhere else in the Edgeworth box, and we should be able to find a Pareto efficient point. But yeah, so that is going to be general equilibrium and economic welfare, at least for the points of this class. This is also the last recording that we will have for content in this class. And so you should be able to finish the end of this and be able to take the midterm, I mean the final. If you guys have any questions, please let me know. I did inherit this course from somebody else. So if for some reason the homeworks aren't making sense and they're not matching the lectures, like please just reach out to me. I'm more than happy to jump on a Zoom call and we can figure this out. But for the most part, I think you guys should be good to go. And I think you guys should be all set. So if you guys need anything, don't hesitate to reach out. Good luck on the final, all sorts of good things. Thanks for sticking with me. And if any of you guys made it all the way to the end of this and are watching this last video, like thank you so much for everything. I really appreciate it. And yeah, good luck.